Welcome to the course. The topic of this lecture is OSI model. In this lecture, we will discuss about protocols, layered protocol stack, OSI model, and internetworking devices. So, we start with what is protocol? Actually, a protocol is the set of rules or algorithms which defines the way how two entities can communicate across the network. Actually, it allows connected devices to communicate with each other, regardless of any differences in their internal processes, structure, or design. Network protocols are the reason you can easily communicate with people all over the world and therefore play a critical role in modern digital communications. It is similar to the way that speaking the same language simplifies communication between two people. For example, if I am speaking in Hindi or some other language and someone else is speaking in English or some other language, it is very difficult to communicate with each other. But if we both are speaking in same language, it will be very easy to communicate. So network protocols make it possible for devices to interact with each other because of predetermined rules built into devices, software and hardware. Next is what is protocol suite? It is nothing but a collection of protocols that are designed to work together. Single protocol stack. A single protocol that takes data from one computer application and sends it to an application on another computer. The problem with single protocol is it is inflexible. Means if you want a single change, it requires changing the entire application and protocol software. As we said, there were problems in the single protocol stack because that was inflexible. Layered protocol stack comes. This approach is used in networking. Broadly speaking, the task of computer network is data communication, but if we are talking in detail, there are a number of steps involved in this process. In order of designing a network architecture in a flexible way, the layered approach came. Layering means divide the functioning into number of steps where the function of each step is clearly defined. Actually, this layered arrangement is not confined to networking, and how it works is probably best understood if you compare it to the real life example. So let us take an example of real world, like a parcel service between two offices. The task is simple. Send parcels between people in each office. First, we will divide the task into two distinct processes. First, take a package, wrap it and address it, and then send it to the destination. And at the receiving end, first receive the package and then deliver it to the recipient. Here is a simple diagram to illustrate this process. Typically, you would have an internal mailman that collects the parcels from the senders and takes them to a mail dispatch room. The, the parcels are placed in a van by the dispatcher and then driven to the remote office. And at the remote office, The parcels are first received by the dispatcher and placed into a tray for the mailman. Then the mailman collects the parcels and delivers them to the recipients. You can easily see in this diagram this process. But the question really is, what is the advantage of splitting the task into different layers? The answer is that any of the layers can be changed without affecting the other layers. So, if, for example, if we decide to use a train instead of a van to transport the message between the offices, we could do so without affecting the mailman. In fact, the mailman doesn't know and doesn't care how the parcels are transported between the offices, as all he does is collect them and pass them to the delivery man. So, on the basis of this layered approach, a very well-known model called OSI model is described. OSI means Open System Interconnection. It is basically called ISO OSI model because it is proposed by ISO, International Standard Organization. OSI model is a reference model for designing of networks. In this model, there are 7 layers and there are hierarchical relationship among these layers. This model helps to design the systematic networking model. In OSI model, every layer is using different technology. So, if you modify design of one layer, need not to change design of other layer. This slide shows the 7 layers of the OSI model. Starting from the lowest layer, the physical layer, then data link layer, network layer, transport layer, then session layer, presentation layer, and the topmost layer is application layer. You can see in this diagram some of the layers are called host to host and some of point to point. What it means? In OSI model, upper 4 layers, application layer, presentation layer, session layer, and transport layers are called host to host or end to end layers. It means they will exist only at the source and destination. It will not exist in the intermediate nodes of the network. The lower 3 layers, physical layer, data link layer, and network layer, are called point to point layers. Point to point means all the node that comes in the path of data transmission. These point to point layers are exist in all the nodes from source to destination, means it including intermediate nodes also. This diagram represents a rough diagram of a network. In this network, node S is a sender and node D is destination, and the nodes A, B, C and E are intermediate nodes. Sender S is sending the data to destination D. Here, the upper 4 layers of the OSI model are existing only at sender S and destination D. These layers are not existing at intermediate nodes A, B, C and E. Here, the lower 3 layers are existing also at all the intermediate nodes. In this diagram, the red line identifies all the point-to-point nodes. Now comes to functions of layers. Physical layer. Physical layer concerns transmit raw bit stream that constitutes your data over a physical medium. Physical medium can be of copper, fiber optics, microwaves, Bluetooth, etc. It can be anything. It made a physical connection between two direct links. Next is data link layer. At this layer, data is termed as frame. Frame is nothing, collection of bits up to some limit. Data link layer ensures that this link is reliable up to some extent. It tries to detect some error in communication if any. Then it will retransmit the data again. It also do flow control. Flow control means if there is a mismatch of speed, it handles between sender and receiver. Next comes to network layer. The main concern of network layer is the routing of packets to the destination. Transport layer. Transport layer is responsible for end-to-end reliable delivery of data. Like, I am sending something to you and asking directly whether you find the item or not. If you say no, then I send it again. Next is session layer. Session layer is responsible for managing sessions. Session means whenever you log in for some application, session created, then finish your task and log out from that application. Then session terminate. Presentation layer. Actually, presentation layer is optional. It can be used if you are doing some kinds of encoding when it is not compatible or encryption. Means you can add something extra at this layer. Something extra with data. For example, if I want to secure my data, then I do some encryption and then send the data. And the last one is application layer. At application layer, number of applications like remote login, file transfer, email, data entry, etc., which want to use networks for data transmission. A point to note here, it is not necessary for every network to have all the layers. For example, network layer is not there in broadcast networks. Flow of data. This diagram shows how the data is flowing over the network when a sender sends the data for a destination. In this diagram, S is the source node, D is the destination node, and A and B are the intermediate nodes. Data starts from application layer and flows through 7 layers as you can see in the diagram. And data once reaches the physical layers of source node S actually physically gets transmitted to the next intermediate node A. Then it goes up to the network layer of node A. Because only network layer decides where to forward packet, means on which node, and again comes down to the physical layer of node A. And again, once it reaches the physical layer of node A, transmit the data to the next intermediate node, which was decided by the network layer of node A. Same process repeated until it reaches the destination node. Once it reaches to the destination node, data will flow in the reverse direction, means from physical layer to the application layer. Like this, data is flowing in the network. Now comes to the internetworking devices. There are also multiple devices or mediums in the networks which helps in the communication between two different devices which are known as networking devices or internetworking devices. For example, hubs, bridges, switches, routers, gateways, etc. You can see here pictorially they look similar, but functions are different. The first one is repeater. The repeater operates at the physical layer. Its job is to regenerate the signal over the same network before the signal becomes too weak or corrupted, so as to extend the length to which the signal can be transmitted over the same network. An important point to be noted about repeaters is that they do not amplify the signal. When the signal becomes weak, they copy the signal bit by bit and regenerate it at the original strength. Next device is hub. A hub is basically a multi-port repeater. A hub connects multiple wires coming from different branches. Hubs cannot filter data, so data packets are sent to all the connected devices. Also, they do not have intelligence to find out best path for data packets, which leads to inefficiencies and wastage. It operates at physical layer. Next device is bridge. Sometimes it is also called layer 2 switch. A bridge operates at data link layer. A bridge is a repeater with add-on the functionality of filtering content by reading the MAC addresses of source and destination. MAC address is nothing but physical address of the device. It is also used for interconnecting two LANs working on the same protocol. Next comes to switch. A switch is a multi-port bridge with a buffer and a design that can boost its efficiency and performance. A switch is also a data link layer device. The switch can perform error checking before forwarding data. That makes it very efficient as it does not forward packets that have errors and forward good packets selectively to correct port only. Next is routers, also it called layer 3 switch. A router is a device like a switch that routes data packets based on their IP addresses. Router is mainly a network layer device. Routers normally connect LANs and WANs together and have a dynamically updating routing table based on which they make decisions on routing the data packets. Next device is gateway. A gateway, as the name suggests, is a passage to connect two networks together that may work upon different networking models. They basically work as the messenger agents that take data from one system, interpret it, and transfer it to another system. Gateways are also called protocol converters and can operate at any network layer. Gateways are generally more complex than switch or router. This slide shows a typical internetworking structure. Here you can see different LANs, WANs, and they are connected with bridges, routers, and gateways. This is all about OSI model. In the next lecture, we will talk about TCP/IP protocol stack. Thank you.